So, hello everyone, how's it going? My name is Dan the Tutor. For those of you who don't know me, I have been a tutor now for about 3 years since 2020. Technically, I tutored before that in college. I am now 26 years old, graduated from Penn State main campus with a degree in electrical engineering. And today I am here to help you learn pre-calc slash trigonometry for the upcoming fall. I'm assuming you're either in high school or college. Probably most of you are in high school. And this is an 8-week course designed to get your butt in shape. And so you basically are at a huge advantage to your classmates if you put in the time, do the homeworks, actually put an effort into this. This really is a really good curriculum. All for free, by the way. Many of you are probably wondering, why am I doing this for free? I'll tell you at the end. But until then, if you have any questions, please let me know. Don't raise your hand. Don't post in the chat. I'm not going to see it. Just unmute yourself, talk into the mic, okay? If you have any questions, or if I'm going too fast, or if you're still writing. And by the way, I am recording this whole thing. So if anyone does have any questions, just let me know, or you can even, email me afterwards and I'll get back to you. So with that, we're going to get started. Hopefully you all printed out the lesson one lesson plan. I will be posting well, I won't be posting the homework, but I'll be like sending it to all your emails. The homework's already on the Google Drive and everything, but that's going to be due next week. I'll probably be posting the solutions in a couple days after you've had a few days to try it on your own first. And with that, let's get started. Lesson one, solving equations and inequalities. So basically, we need to make sure that you're really strong with equations, inequalities, and just basic algebra in general before we get started with pre-calc and trig. So we're going to talk about the methods of solving equations. Hopefully all of this sounds like review to you already. So method letter A is isolating x, and we do that by getting x on one side and everything else on the other side. So in this example, 3x minus 4 equals x plus 8. All you need to do is subtract x from both sides and add 4 to both sides. So now 3x minus x, that's 2x. On the right, it's 8 plus 4, so 12. Then you just divide both sides by 2. We get x equals 6. Hopefully that wasn't too bad. So that's the first method we have. That's called isolating x. We do it whenever it's just x, just x. Factoring is what we do whenever you have x squared. As you can see here, there's an x squared in this problem. Now actually, this is a very tricky one because I set x squared plus 2x equal to 3. We always want to have the one side set equal to 0 in order to factor. So in other words, if I want this to equal 0, the very first thing I'm going to do before I do anything else, I'm going to subtract 3 from both sides. So now I've got x squared plus 2x minus 3. That's equal to 0. We love that because now you can actually factor this. Now that's equal to 0. And so if I want to factor this, well, this is about as easy as it gets when it comes to factoring. The factors of 3 are 1 and 3. Since it's minus 3, one's positive, one's negative. Hopefully this all makes sense. I don't even need to explain it. But you should get x plus 3 times x minus 1 equals 0. Just as a reminder, if you're ever unsure about factoring, you can always check your work by foiling or distributing. And then finally, the last step is setting both of these equal to 0. Hopefully you remember x is just going to be negative 3 and positive 1. It's the opposite of the factors themselves, and that will happen every time. So that's it for part B. Next, the third method we have of solving equations is the quadratic formula. You want to use the quadratic formula whenever you can't factor. We love factoring. Factoring's easy. I've never met a single kid in all my years who said, I like the quadratic formula, myself included. So let's just first remind ourselves what the quadratic formula says. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. A lot of my students out there do not put the whole thing. They'll just put like this part over 2a. You need to make sure the whole numerator is over 2a. And in this example, a is 2 because of the x squared. B is also 2 because of the 2x. And c is equal to negative 5. So now all I need to do is plug in. So x equals negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times a times c, which is going to be 4 times 2 times negative 5. And then all of that's divided by 2 times a is also 2. And so now we just need to start worrying about simplifying this, which I'm going to do on another page because I'm out of room. But we've got x equals negative 2 plus or minus the square root of 4, and then 4 times 2 times negative 5. The double negative ends up making it a positive. And so what we're going to get here is plus 40 now. Does that make sense to everyone? Any questions so far? Okay, continuing. Divided by 2a. 2 times 2 is 4. I'm going to try and simplify the square root, so that's like the square root of 44. If you think about it, square root of 44 can break down into root 4 and root 11. And we know the square root of 4 is just 2. In other words, this is just 2 root 11. So now that's what I'm going to plug in there instead of the square root. X equals negative 2 plus or minus 2 root 11 over 4. And honestly, you can probably leave your answer like this. The one thing I do want to say is that the 2's will cancel. Like that 2 cancels, that 2 cancels, and that 4 becomes a 2 in the denominator now. So technically, you're left with x equals negative 1 plus or minus 1 root 11, which you don't have to write 1 root 11. You can just write root 11, and then divide it by 2. And there's our answer for the quadratic formula question. This form is fine, by the way. You don't have to simplify it any more than this. This is perfectly fine. Any questions so far? Anything on that first page? For those of you who joined late, this whole thing is going to be recorded, so you can just check out the recording for any parts you missed. No problem at all. I'll also be taking questions at the end as well, so if you have any questions, just stick around for the end. So now we're almost done. There's just 2 more methods we need to talk about for solving equations. One is taking the square root of both sides. I swear, I don't understand where you kids went to school. When I was a kid, we learned that when you take the square root of both sides, it's plus or minus. In the 3 years that I have been tutoring for algebra, pre-calc, even calculus, I swear only about 2 students have remembered the plus or minus. It's wild to me. But you do the square root whenever you have, 2x plus 4 squared, for instance. The first thing you do is take the square root of both sides. And like I said, the right side, or at least the other side, is going to be plus or minus. So the nice thing about a square root and the squared is that they end up canceling out. In other words, on the left side, you just have 2x plus 4. And on the right side, you're going to have plus or minus square root of 9 is 3. Now, the plus or minus is very important here because since we're not done with the problem yet, what would be the best thing to do is to write it out twice. It would be best to write 2x plus 4 equals 3, and then next to that, 2x plus 4 equals negative 3. We're going to solve the equation twice, once for the plus, once for the minus. So now it's just basic algebra. Minus 4 from both sides, 2x equals negative 1. Hopefully you're not afraid of fractions. The answer is x equals negative 1/2. And then for the other one, same idea, minus 4, 2x equals negative 7. Again, I'm not afraid of fractions. Hopefully you are not either. The other answer is x equals negative 7/2, 7 over 2. And that's what we do whenever you have the thing squared. Notice that this is not factoring, this is different, and honestly, it's a lot easier than factoring in my opinion, as long as you remember the plus or minus. Okay, and that's it for that one. Part E, the last method we have, square both sides. You do this whenever it's the opposite. I give you the square root. I want to get rid of the square root. What do? I square both sides. So in other words, square root of 2x plus 10 squared equals x plus 1 squared. Once again, the square root and the squared cancel. The left side is just 2x plus 10. On the right side, it's tricky. Don't do plus or minus. That would be wrong. But instead, x plus 1 squared, for those of you out there who think, oh, it's x squared plus 1, like this, you would be incorrect. This is horribly wrong. Instead, you need to remember x plus 1 squared is really like the FOIL of x plus 1 squared. So really, you got to do x squared plus 1x plus another 1x plus 1. That would just reduce to x squared plus 2x plus 1 after the FOIL. And then on the left side, we still have 2x plus 10. Now, this is quadratic because of the x squared here. That does not mean quadratic formula. I'm not that evil. But what I will say is this. You want to subtract 2x minus 10 from both sides because you want this to equal 0. So on the left side, you have 0. On the right side, we're going to have x squared. The 2x's cancel out, and you got minus 9 here. Now, if you want to factor this, which we can, x squared minus 9, that's just going to be 0 equals x plus 3 times x minus 3. It's a difference of two perfect squares. And then your answer is x equals plus or minus 3. Notice I am not circling my answer yet. Emphasis on yet. Why is that? Because whenever you square both sides, you always need to check for extraneous solutions. You've probably heard of this term before, extraneous solutions. When do you do it? You do it whenever you square both sides. So here's what I'm going to say. I'm going to first check x equals positive 3. How do I check it? I'm literally going to plug it into my original equation right here, 3 for both x's, and they need to equal each other. And if they don't, it's an extraneous solution. It doesn't match. So it's going to be the square root of 2 times 3 plus 10, and I'm setting that equal to 3 plus 1. 2 times 3 is 6. 6 plus 10 is 16. Square root of 16 equals 3 plus 1, which is 4. That is true. Check mark. 3 is good. 3 is a good solution. Now we just need to do the same thing with negative 3. So for negative 3, it's going to be the same idea. Square root of 2 times negative 3 plus 10 equals negative 3 plus 1. So 2 times negative 3 is negative 6 plus 10 is 4. And then on the right side, negative 3 plus 1 is negative 2. Notice square root of 4 is positive 2. It does not equal negative 2. Negative 3 is not a good solution. The only good solution is x equals positive 3. And that's the answer for that one. Any questions? Okay, great. That's all the methods of solving equations, except for one. There's one more thing I want to talk about. That is the absolute value function, because those can be very tricky as well. So first, let's just look at the graph of this. It's the absolute value of x minus 3 minus 1. If I were to make a table of values here, let's just say 0, 1, 2, and 3 for x. They're technically, you can do any points for x. I'll just choose these four. Doesn't matter. Remember what the absolute value means. Whenever it's negative, you make it positive. So for instance, when I plug in 0 for x here, I'm going to say absolute value of 0 minus 3 minus 1. This is equal to the absolute value of negative 3 minus 1. Remember, absolute value is going to make that positive 3. So positive 3 minus 1, you get 2. So 2 is the answer for that one. Honestly, you can just follow the graph here. It's going to be, when you plug in 1, you're going to get positive 1. When you plug in 2, you're going to get 0. And when you plug in 3, you're going to get negative 1. And if you don't believe me, then on your own, actually check out, try plugging in these x values. See if you get these y values. You should. But that doesn't answer the question of how do you solve this equation, right? How do I solve absolute value functions? Well, let's go ahead and set this equal to 0. So what I'm saying is 0 equals x minus 3 minus 1. 0 equals x minus 3 minus 1, right? And here's what I want to do. First, add 1 to both sides. So 1 equals the absolute value of x minus 3. And now the question is, how do you get rid of absolute value symbols? The answer is take the plus or minus of the other side. Just like a square root, for instance. So what I'm saying is plus or minus 1 equals x minus 3. And now the absolute value symbols are gone. But what do? I need to set this equal 2 different times. So for instance, positive 1 equals x minus 3, and negative 1 equals x minus 3. That's what we do. And then to solve for x, this is super easy. Just add 3 to both sides. One solution is x equals 4. The other solution is x equals positive 2. There's no extraneous solutions you have to worry about. This is it. And by the way, the answers were 2 and 4. If I go back to my graph, isn't that where the graph crosses 0, the x-axis? Yes. And that also proves it's a solution. Of course, you're not always given the graph, or else it wouldn't be very hard, would it? Any questions on absolute value functions? Okay, great. And I think for the rest of the time today, we are just going to be doing some practice problems. Honestly, I don't think this is going to be a full hour, if you ask me. But that's okay, because any time we have at the end, I can either take questions, I can go over more advanced topics. I'm not going to go on to lesson 2 until next week, I promise that. But if you do want to stick around at the end and do some complex examples of this, you're more than welcome to. I have this in my calendar until 7 anyway. So here we go. Solve for x if there's no solution, say no solution. So for this first one, what strategy is this? This is just a normal solve for x, isolate x. In other words, add x to both sides, subtract 4 from both sides. The left side will be 5x, the right side will be negative 2. Divide both sides by 5, x equals negative 2/5, and that's a perfectly good answer. Any questions on that one? Okay, for number 2, what do? It's factoring because it's x squared. And it's already set equal to 0. Look at that. We're happy because it's already 0. If that was not 0, we'd have to make it 0 by subtracting it to the other side. But now, again, I don't think I could have asked an easier question to factor. I don't know why I decided to be easy on you guys today, but believe me, in the future, I am not. So it's x plus 1 times x plus 2 equals 0. And then the solutions are just the opposite. X equals negative 1 and minus 2. And we can just separate those answers by commas. Now for number 3, there's actually 2 ways I can solve number 3. I'll show you both. The first thing we can do is you can add 75 to both sides. So then 3x squared equals 75. You divide both sides by 3. That means x squared equals 25. And then you take the square root and you get x equals 5. Does anyone see the mistake I made? Anyone?
Isn't it plus minus?
Plus or minus, thank you very much. So it's plus or minus because we took the square root, and so our answer is x equals positive 5 or negative 5. Now, as promised, there is another way you can do this. I'll show you. So 3x squared minus 75 equals 0. The other thing you can do is you can pull out the 3. So like 3 times x squared minus 25 equals 0. This is called greatest common factor. Most kids do not like greatest common factor because it's too complicated. But you can do this. Then the 3 just goes away because what's 0 divided by 3? Still 0. So x squared minus 25 equals 0. And then you can factor this because it's a difference of 2 squares. You get x plus 5 times x minus 5 equals 0. And then you get the same answer, x equals plus or minus 5. Just another way of doing it. Which way is the right way? Trick question. They're both right. I don't care which way you do. Any questions on number 3? Okay, number 4. Question for the audience. Who knows how to factor this?
You can't factor, you need a quadratic formula.
Exactly. Quadratic formula is going to be the ticket for this one. And by the way, whenever this first number here is not just x squared, it's 2x squared, 5x squared, negative 3x squared, that's typically when I recommend doing quadratic formula. So that means x equals negative b. Since b is negative 6, it's like a double negative, so it's actually positive 6, plus or minus the square root of b squared. What's negative 6 squared? Well, that's going to be positive 36. I'll write that in the next step because any negative number is positive. Or negative number squared is positive. That's what I mean. And then minus 4ac, 4 times 2 times 5. All that's positive. And then divided by 2a, or 2 times 2. Now let's worry about simplifying this. So numerator, x equals 6 plus or minus the square root of, as I said earlier, negative 6 squared is positive 36 minus 4 times 2 times 5, that's minus 40, all over 2 times 2, which is 4. Let's look at that square root for a second. That square root's going to be 36 minus 40, square root of negative 4. That's a problem. You cannot have a negative square roots. No negative square roots. If you plug that in your calculator will cry because it can't handle it. Unless, of course, you set your calculator to deal with imaginary numbers, but we're not going to talk about that. So basically, the answer is no solution, and that's absolutely fine. No solution. Any questions on that one? By the way, I do not think you will be dealing with imaginary numbers at all in pre-calc. I know I did not when I was in your shoes. Of course, it depends on the high school, but most high schools do not deal with imaginary numbers in pre-calc. So that's it for number 4. Let's keep going. Next, number 5. X plus 1 squared equals negative 4. So the first thing we do, since this is a squared one, as you can see right there, the first thing you're going to do is you're going to take the square root of both sides. So square root of x plus 1 squared equals the square root of negative 4. And again, you can't take the square root. Error. You cannot take the square root of negative numbers. Therefore, again, immediately the answer is no solution. And by the way, the reason why this makes sense for in the context of math, when you square any number, it makes it positive. You will never get negative 4 after you square it. That's impossible. So no solution. Now on the right side, you're not getting out of the square root method that easily because we have another one lined up for number 6. So first thing we do is square root of both sides. This one's not an error. And so don't forget plus or minus because we're taking square root. Technically, I forgot it over here, but it didn't matter since there was no solution. So square root and squared cancel. You get 4x minus 1. On the right side, you have plus or minus 4. Remember what we do for plus or minus. You set them both equal to positive 4 and then negative 4. You just write it out twice. Fastest way to do it. Okay, so adding 1, you get 5. 4x equals 5. And x is going to equal 5 over 4. That's one of our solutions. And then plus 1 would get you 4x equals negative 3. That means x equals negative 3/4. And there's our two solutions. Remember, you do not need to check for extraneous solutions. That's only when you square both sides, not square root. Speaking of squaring both sides, that's going to be number 7 and number 8 here. So for instance, with number 7, we have the square root of 4x plus 5. We're going to square that equals 5 squared. So the squared and the square root cancel out. You get 4x plus 5 equals 5 squared is 25. And now we just solve like normal. So minus 5 from both sides. 4x is going to be 20. And then divide by 4. X is equal to 5. Again, you need to check for extraneous solutions. So we're actually going to plug in 5 into the square root to make sure it's right. So the square root of 4 times 5 is 20, plus 5. And we want to make sure that equals 5 on the right side. So 20 plus 5 is 25. Square root of 25 is 5. Looks like we get 5 equals 5. Check mark. We're very good. So 5 is the right answer. And now for this one, same idea. Square root of 10 minus 2x equals 4. Do the opposite of the square root. Square both sides. Again, this is just a pretty easy one. So the square root and the squared cancel. 10 minus 2x equals 16. I'm going to subtract 10, so negative 2x equals 6. And then divide by negative 2, x equals negative 3. And before I circle that answer, let's check if it's extraneous or not. So it's going to be the square root of 10 minus 2 times negative 3. So 2 times negative 3, that's going to be positive 6, right? So 10 plus 6, that's the square root of 16, and the square root of 16 is 4. Check mark. That's what we wanted to equal. So it looks like negative 3 is the answer to number 8. Any questions on that one? Okay, fantastic. Now for the next two, we have our absolute value problems. Remember how we get rid of absolute values? You just need to say plus or minus. So in other words, plus or minus 5 equals 2x minus 3. So that means for the positive, 5 equals 2x minus 3. And the negative, negative 5 equals 2x minus 3. So all I need to do is for the left one, add 3 to both sides. 8 equals 2x. And then divide by 2, x equals 4. There we go. And then for the other side, add 3 again. So negative 2 equals 2x. And then just divide by 2, x equals negative 1. And there's our two solutions. I don't need to check for extraneous solutions. That's it. And then for number 10, well, what do we do this time? This time it's not just the absolute value. If you want to solve for absolute values, first you got to isolate the absolute value. What does that mean? It means you subtract 6 as your first step. So the absolute value of 3x minus 1 equals negative 4. And then, your absolute value can't be negative. It's literally impossible. Because absolute value is going to make the number positive. You'll never get negative 4. Once again, the answer is no solution. Always be careful of that. There's quite a few no solutions we've had today. So you just got to be careful of that. You'll be fine. Any questions on the first 10? If not, we're going to head into our final topic of the night, which is solving inequalities. So inequalities, exactly the same as solving equations. Only two things you need to worry about. Number one is you actually have to graph this at the end and the greater than less than sign. And then the other thing you need to worry about is when you divide by a negative number, you switch the direction. And I'll explain that more when we get to that problem. But for the first one, you just subtract 5, just like normal. 3x is greater than negative 3. Divide both sides by 3. X is greater than negative 1. There's your answer in inequality form. And then if you want to graph it, it's going to look like this. Here's negative 1. Since it's greater than and not greater than or equal to, it is an open circle as opposed to a closed circle. And then you want to fill in the graph to the right because it was greater than. That's a note I want to make. Whenever it's greater than, you want to fill in the right side. And whenever it's less than, you want to fill in the left side. Any questions there? Okay, great. Now for number 12. For number 12, same idea. I'm going to subtract 9 from both sides. So that means negative 2 is less than or equal to negative 4x. Now this is what I was referring to earlier. Whenever you divide by a negative number, you need to switch the direction. So in other words, negative 2 over negative 4, that's positive 1/2. And now it's greater than or equal to x because you switch the direction when you divide by a negative. So I don't like this answer personally. I would always write it as x is less than or equal to 1/2. Always have the x go first. It's just going to make your life easier. And then for filling out the number line, here's 1/2. It's a closed circle this time because of the equal sign, less than or equal to. And then since it's less than, you fill out the left. Okay, so there's our answer for that one. Honestly, inequalities, not that bad. Most of the same stuff we've been doing already. Any questions so far? Okay. And then with that, we just have the last two examples. These two are actually legitimately hard, and that's because they're squared. Now, there's one thing you got to be careful. Whenever you have quadratic and squared, let me show you what you do not want to do. Do not write this down. I'm telling you, don't do this. What you do not want to do is add 4 to both sides. X squared is less than 4. Take the square root plus or minus. X is less than plus or minus 2. That doesn't make any sense, mathematically speaking. None of this, it was good math. Now, what you have to do instead is this. You have to factor it. You have to factor this. That's what you have to do. So to factor this, it's going to be x plus 2 times x minus 2. Again, difference of two squares. That's less than 0. And now here's what you do. You don't set both of them. I mean, you can set them equal to 0. Like you'll get x equals 2 and negative 2. That much is true. I agree with that. But now what you need to do is you need to test your points. You need to test your points. Let me show you how to test them. First, set up a number line. This is not the final answer. This is just a separate number line used to test my points. On the number line, I have my solutions, negative 2 and positive 2. So here's what I'm going to say. I am going to test a point in this region over here. What's that region? It's numbers less than negative 2. What's a number less than -2? -3, -5, -1 billion. I don't care. I think -3 is probably the easier one to test. So let's test x equals -3. And what do I mean by test it? Let's actually plug it in this inequality. -3 squared minus 4. -3 squared minus 4. -3 squared is +9. 9 minus 4 is 5. And 5 is greater than 0. Remember what we said right here. I want it to be less than 0. In other words, this is wrong. So what do? I'm going to put an X on my test here, my test number line. If it was right, I would put a check mark or true or whatever you want to write. But it's wrong, so X. Now, next point is 0. So I plug in 0 for x. When I plug in 0, that's going to be 0 squared minus 4. That's just -4. And -4 is less than 0. That's what we want, because we want x squared minus 4 to be less than 0. Check mark, because it's true. That's one of our solutions. That means any point between -2 and +2 will work. I'm talking about -1, 0, +1, even 1.999. All those points are going to be true, they work. And then we put in a point greater than 2, such as +3, although you could do +4 or 10 or whatever you want. I'll do +3. And when I plug in 3, it's 3 squared minus 4. That's 5 again. And 5 is greater than 0. False. Wrong. So it looks like the only region I want is from -2 to +2. And so what that means is my answer, I'm going to write like this. -2 less than x less than 2. And then if I wanted to graph that on a number line, the number line would look like this. -2 here, +2 here. Notice no equal signs, it's just less than. So open circle, and then the answer is the sandwich here in the middle, exactly where the solution set was true. If it was ever the outside, I'll show you what that looks like in the next problem. But any questions on number 13? Okay, now for the last problem of the night, number 14. I told you it wouldn't take an hour, which is honestly good for me. It means I have more time to prepare for my next lesson. But as promised, at the beginning of this lesson, I said I was going to answer the question, why am I doing this for free? Why did I put together this 8-week course? Who is this guy? What's he doing? And how is he making money off of this? The short answer is no, I'm not making money off of this. I'm not going to try and weasel my way and give you some, whatever. But here's what I am saying. I became a tutor because I want to be the greatest tutor of all time. I want people to go back and say, Dan the tutor was the Michael Jordan of tutoring. Even better, I want them to say Michael Jordan was the Dan the tutor of basketball. So I really do. I want to be the greatest tutor ever for you guys. I want you to see another tutor after me when you're in college or high school, and you want to say, wow, that guy sucked compared to Dan the tutor. That's my selfish goal in all of this. Now, also, if you do know anyone who's a classmate or maybe even a friend who goes to another school or whatever, and they're taking anything from Algebra 1, Algebra 2, Pre-Calc, Geometry, Calc 1, Physics 1, whatever, and I have these online summer courses for this, I do want you to refer them to me because I want these classes to be as big as I possibly can get them. Even the fact I have 6 people here today or 5 people is amazing. So thank you all for coming out. We're not done yet, but if you can help me become the greatest tutor of all time, then that would be greatly appreciated. And so for the last one, x squared minus 8 greater than 2x. Greater than or equal to 2x. So the first thing you got to do is you have to set it equal to 0. That's going to mean subtracting 2x from both sides. So we get x squared minus 2x minus 8 greater than or equal to 0. Like we said before with these squared ones, the quadratics, you have to factor it. How does this factor? Well, the factors of 8 are 4 and 2, and so it's going to be x minus 4 times x plus 2. That is greater than or equal to 0. And so again, I solve for x. X is either going to be positive 4 or negative 2, which means my solutions are the following. Well, I have to set up the number line first. I'm not going to figure this out right away. But first I put my solutions on the number line, negative 2 and 4. And then I have to test some points. So let's test a point over here first to the left. Let's test -3, for instance. X equals -3. So x squared minus 8 is -3 squared minus 8. And we want to say that's greater than or equal to 2 times x, which is -3. So -3 squared is 9. 9 minus 8 is +1. Is that greater than or equal to -6? True. 1 is greater than -6. So that's a true for the left region. Now for 1 in the middle, between -2 and +4. Let's test 0. 0 is the easiest number to choose here. So that means 0 squared minus 8. We want to check if that's greater than or equal to 2 times 0. So on the left side, I get -8. Is that greater than or equal to 0? No, false. False. So the middle is wrong. And then the next point we're going to test is 5. Maybe you already know it's going to work. You're going to say true because it always alternates. But that's actually not true. It doesn't always alternate. It doesn't always go true, false, true, false. Just most of the time, I will admit that does happen, but not every time. So you still have to check. So we get 5 squared minus 8. Is that greater than or equal to 2 times 5? Well, 5 squared is 25. 25 minus 8 is 17. Is that greater than or equal to 10? The answer is yes. And so that's true as well. And so now if I want to write out my answer, I need to write two ranges because the left side's right and the right side is right. So here's what I'm going to write. X is less than or equal to -2 and x is greater than or equal to 4. I have to give two answers and I need to put the and in the middle. And that's because this is not the sandwich. What do I mean by it's not the sandwich? I'll show you on the number line. So here's -2, here's +4. Again, close circles because we have greater than or equal to. And then less than -2 is the left here. Greater than 4 is the right side. This is what I mean by the sandwich. The sandwich would be in the middle. This is like an inside-out sandwich. So that's the answer for the inequality form and the table of values in the graph. And that's it. So if you do have any more questions, please stick around. I would be happy to answer them. I will be submitting the homework later tonight, probably around 9 o'clock. We'll see. And if you want to stick around at the end, that's fine too. I'll be posting the video for this also tonight. Not sure exactly what time, but you'll all get an email for that. So again, thank you all for coming, and I can't wait to see you next week. Take care, and bye-bye.